This week's Moment of Science is sponsored by Charleston County Parks.
Fog, smog, and smoke, their impact on us is determined by an invisible presence in our atmosphere, an inversion, or a flip in temperature. In our troposphere, the layer of our atmosphere closest to the surface and where almost all of our weather takes place, temperatures get cooler as you rise higher up. Sometimes this trend flips with warmer air above cooler air, creating a stable layer of the atmosphere that acts like a lid, trapping everything below it. Let's do a quick demonstration. You can try this experiment along with me at home. As a fluid, both water and air behave the same, so we'll use water in this experiment. I've color-coded them based on temperature, yellow for warm water and blue for ice cold. Watch what happens when I add the cold water to the bottom. It doesn't mix, but stays stagnant as the less dense warm water sits on top of the denser cold water. This is what happens when we're under an inversion. The cooler air at the surface, with all the pollutants, smoke, and fog, is trapped, unable to mix, all because of a change in temperature with height. In extreme cases, especially out west, you can actually see this normally invisible inversion layer as the dividing line between a dense cloud of smog with clear skies above. Here in the low country with much less traffic, smoke is the bigger issue, with forest fires sometimes causing a haze over the area. Officials in charge of controlled blazes know all too well this possibility, so they make sure to manage a burn with inversions in mind. Timing a burn is everything, as every day a temperature inversion begins to form around sundown as the ground cools while the air above remains warmer. This nighttime inversion lasts through the night and a couple hours after sunrise as the sun warms the surface, eroding that temperature inversion. We can see that beginning to happen in our experiment as that cool water warms with more green, indicating mixing. That's one way to get rid of inversion. The other way is a whole lot quicker. Mixing it for ourselves as winds pick up or a weather system approaches and our air clears up. For this week's Moment of Science, I'm Storm Team 2 meteorologist David Dixon.